Using Tuna Roe for Shrimp Maturation Diet, Gong, University of Guam, July 2012. Shrimp aquaculture has continued its fast growth in the past 2-3 decades. Recent development shows Penaeus vanami has become the dominant shrimp species cultured worldwide. Among all the production costs, the feed remains as a major cost. It has been a challenge to develop a nutritionally complete, cost-effective, and biosecure maturation diet for shrimp broodstock. The Western Pacific Islands are the most important tuna fishing area in the world, which yield 1/3 of world tuna production. Pelagic tuna, such as yellowfin and other species, represent a substantial resource for the entire region. Landing, transshipment, and processing of tuna from distant water fishing fleet has become an important component of Guam's economy. During the tuna processing, the long are harvested, and Tuna Roe, along with other parts of the fish, usually are treated as a waste product and sent to the local landfill. Fish roe account for about 16% of the fish scraps and about estimation of 30 tons of fish roe being dumped annually. Tuna accumulate and preserve energy and essential nutrients in their role for the production of the next generation. These nutrients are also found in some of the commonly used shrimp maturation diets, such as bloodworm and squid. It is unknown how effectively Tuna Roe could boost the maturation process of shrimp from both health and nutritional perspectives. Funded by USDA CTSA, this project was undertaken to develop techniques for increasing the values of tuna fish roe and explore the potential usage as an aquaculture feed ingredient in Penaeus vanami maturation diet, and to do so in a sustainable manner. In this project, we conduct research to determine nutritional values of Tuna Roe, examine its health status, develop a practical way to incorporate it into shrimp maturation diet, and evaluate its effectiveness as a maturation diet. And this has been illustrated in this drawing. A total of 23 sets of freshly harvested yellowfin Tuna Roe were collected from a local fish landing company throughout the dry and wet seasons on Guam. Freezing dry and oven dry were compared, and they both gave similar results. To establish a standard protocol in processing the raw tuna fish roe samples, a series of freeze-drying experiments was conducted prior to our nutritional analysis. Based on our experiment, we choose to use 30-gram Tuna Roe samples and freeze drying for 48 hours. Following the standardized drying protocol, 6 pool samples were shipped to 2 labs at the University of Hawaii for biochemical analysis and also for fatty acid profiles. Baseline information of Tuna Roe nutritional value indicated that fish roe is abundant in protein content, which was about 74% of dry matter. The total fatty acid accounts for 3.9% of tuna roe in dry matters, with a standard deviation of 0.71% among 6 pooled tuna fish roe samples. Previous study on PUFA and HUFA, which is unsaturated fatty acid profile of natural foods for pronounced Vietnamese, suggested that 3 HUFA, which are ARA, EPA, and DHA, are needed for dietary inclusion in the maturation process. Bloodworms are generally considered as a gold standard of shrimp maturation diet. Therefore, the fatty acid profile of tuna roe was compared to that of bloodworms to assess the suitability of fish roe of shrimp maturation diet. Among the total fatty acid fractions, ARA comprised 5% of total fatty acid in tuna ovaries, which is slightly higher than that in bloodworm, which is 4%. On the other hand, significantly lower EPA content was present in tuna roe as compared to that in bloodworm, 6% versus 29.3%, while DHA in tuna ovaries is triple the amount in bloodworms. As a result, the EPA and DHA ratio is far lower in tuna roe, which is 0.16, than in bloodworm, which is 2.27, the latter of which are similar to that from shrimp ovary tissues. However, the relationship between the dietary EPA and DHA ratio and shrimp maturation remains unknown. Following the published PCR protocols for white spot syndrome virus, infectious hypodermal and hematopoietic necrosis virus, and RT-PCR protocols for Tora syndrome virus, yellowhead virus, and infectious mild necrosis virus, diagnosis was performed on the 6 pooled fish roe samples in the molecular lab at University of Guam. The PCR diagnostic result of all 6 pooled samples verified that tuna roe was free of these shrimp viral pathogens, which include white spot, TSV, IMNV, yellowhead, and IHHMV. Semi-moist diet was formulated based on the nutritional value of tuna roe and other feed ingredients to achieve suitability texture and water stability. The fish roe-based maturation diet was made on a daily basis and kept in the freezer at -20 degrees until ready to use. 20 minutes prior to each feeding, the diet was taken out from the freezer and cut into small pieces about 2 grams each for feeding to the broodstock. Stage 1 comparison was made between tuna roe diet and regime A, which consists of 50% commercial maturation diet and 50% squid, and under natural mating conditions. The evaluation of dietary effect was made using shrimp broodstock reproduction index such as ovary maturity level, number of mating per day, eggs per spawn, hatching rate. The semi-moist tuna roe diet yield a consistently inferior reproductive performance as compared to this control, as shown in this table. In both stage 2 and 3 experiment, we compare the semi-moist diet with the same commercial diet alone, which named as region B. During the stage 2 comparison, broodstock from both sexes was fed the feed and natural mating was adopted. Results showing that similar effects were achieved on most reproductive traits except that significantly fewer females reached maturity levels of stage 4 and consequently a lower number of female spawners were found in the Tuna Roe dietary treatment. The latter may be the result of the lower sperm quality and male broodstock from the fish roe dietary group. Therefore, the stage 3 comparison consists of the same feeding regime as stage 2, which compares semi-moist tuna diet versus region B, the commercial diet, but only female broodstock were used after the unilateral eye ablation was performed. As soon as the female brooders reached stage 4, artificial insemination was applied by utilizing the best spermatophore available from the males that was fed region A. Semi-moist diet appeared to produce similar eggs per spawnings, fertilization rate, and hatching rate in shrimp brooders as the region B, though the maturity of female to stage 4 was still a little behind. The project explored the possibilities of utilizing the local available tuna roe for shrimp maturation diet and provided some baseline information in terms of nutritional and health aspect of such diet. The information generated could be helpful in developing a cost-effective and nutritionally complete biosecure maturation diet. We did find from this study that tuna roe is high in HUFA content, especially ARA, and much higher DHA compared to bloodworm. They are free of shrimp viral pathogens. This is a good attribute for rearing SPF shrimp. Tuna roe also could be useful or suitable for developing semi-moist diet with proper texture and palatability. They seem to be more favorable to female reproduction than to male reproduction, and this approach could be value added as both nutritional value and environmental benefit are realized. And we hope that this study serves as a starting point for further development of diet, which could benefit a larger region than Guam and CNMI if we could identify the other essential nutrients and incorporate them to the diet formulation in order to promoting shrimp maturation and reproductive performance. Thank you for your attention.